In this video, I'm going to find the derivative of square root of x using the definition of derivative. You know that the derivative is defined as limit h approaches 0 f of x plus h minus f of x divided by h. So what I'm going to do, I'm going to just take this function straightforward, apply it right here. So your f of x is equal to square root of x, and for simplicity I am restricting the function to positive values only. Okay, so what is f of x plus h? So f of x plus h, which by the way is going to be nothing but square root of x plus h. So under the square root you will replace x by x plus h. Now if I were to plug it in to this limit h approaches 0, f of x plus h, which is square root of x plus h minus f of x, which is square root of x, all of it divided by h. And for simplicity, I'm just going to put the h in the denominator as 1 over h so that I can write it easily. Limit h approaches 0, this is going to be 1 over h times. Now look, what I'm going to do, I'm going to take this square root of x plus h minus square root of x, okay? I'm going to divide it by square root of x plus h plus square root of x and multiply it by square root of x plus h plus square root of x. The reason I did this is to get rid of the radicals, get rid of the square root in the numerator. Look, this was negative square root of x plus h minus square root of x. I multiplied by square root of x plus h plus square root of x and divided by the same thing. And the reason I did that is this is going to be, the numerator is going to be the difference of squares. If you look at it carefully, you notice that this looks like a minus b times a plus b, right? Which is a square minus b square. That means the difference of squares. Now these squares are going to cancel the square roots. So that's going to give me the following: limit h approaches 0, 1 over h. So now the numerator is going to be square root of x plus h whole square minus square root of x whole square using the difference of squares formula. Now what in the denominator we will have square root of x plus h plus square root of x. And let me further simplify this. Limit h approaches 0, 1 over h. Now in the numerator I'm going to get square and square root is going to cancel, and under the square root we have positive values, so we are good there. So it's going to be x plus h, and then square and square root is going to cancel. I'm going to be left with negative x there, divided by square root of x plus h plus square root of x. And then limit h approaches 0, 1 over h times, in the numerator negative x positive x cancel out, this gives you h, and in the denominator square root of x plus h plus square root of x. Now this h and h is going to cancel out. That's going to give you limit h approaches 0, 1 over square root of x plus h plus square root of x. Now let's look at the denominator and evaluate the limit. As h goes to 0, this term becomes just square root of x. So the limit evaluates to 1 over square root of x plus square root of x, which by the way is 1 over 2 times square root of x. So the derivative of this function y is equal to f of x is equal to square root of x. The derivative of this function, which is y prime, we also write it as f prime of x, or dy over dx, many notations, okay, is going to be equal to this number, 1 over 2 times square root of x. And now you can see why I have restricted the value x to the positive number, right? So that I avoid division by 0. I hope that this discussion was helpful. Thank you very much.